Bell ring yet? Are you guys all sanitized? Oh, I got a quiz to give back to you. Hey, you got to take a quiz. So.
Are they in Power School?
Are they in Power School?
Yeah.
I think so. Yeah, they are. Just steal one of those desks out into the hall and shut that door, will you? And then Nicole will remind me to come get you.
Yeah.
So let's see, Maya.
Huh? Yeah.
Samuel. Gavin. Yarwa. Aaron. Nicole. Jammies. So, Alex. Alex. No Alex today? So let's go over this quiz real here, and then we'll talk some trig subs. Oh, was that fun? I felt like I ran a marathon last period. I've never ran a marathon, but that's probably what it would feel like. But it was fun. So numero 10 was this. Sine to the 5th times cosine cubed. Yeah? So I put that all in terms of sine. You could have put it all in terms of cosine. Right? And you would get a completely different answer, but it's equivalent because of the trig identities and a constant. All right? But I just did these. I said, okay, these are sine to the 5th times cosine squared times cosine x dx. Then I change cosine squared to 1 minus sine squared cosine x dx. And then here's where we do u sub. U is sine of x. Du is cosine of x dx. Hey, look at here. And then u to the 5th times 1 minus u squared du. Now, there are lots of people who got here. They got here, they got the hard part done. And then they just win it. Like, I saw people who anti-differentiated this, and this all independently. I saw people who didn't anti-differentiate that at all and then just wrote u to the 5th minus u to the 7th. Someone knocking at the door? Someone was rapping at the chamber door. So we distribute that, friends. And then we anti-differentiate u to the 6 over 6, u to the 8 over 8, and then resub sine to the 6 over 6 minus sine to 8 over 8 plus the cheaps. Cheap. Okay? Question? You did it twice.
I don't know.
Yeah,
As soon as I looked at it,
I think you did it
I
too.
was like,
Yeah, you got the hard part here, like you got to this, and then just like.
I had 2 of the 1 minus squared. I had 2.
Did you put it in terms of cosine?
Yeah.
Yeah, which you can do that. In fact, I would challenge you to do that. Like, try to put that all in terms of cosine and do the problem again, just for fun. Like, see if you can get the answer that what it is. You end up with cosine to the 8th. You actually get, I think you get an extra term in there somewhere.
Yeah.
So, okay, number 2. So this is sine squared 3x. So I first go u right away. U equals 3x du 3 dx. So that's du over 3 is dx. Sine squared u du over 3. Yeah? And then you got to, I mean, hopefully you've got sine squared memorized. If you don't, it makes this a lot more difficult. So I have sine squared memorized like this, 1/2 times u minus sine u cosine u. Then resubstitute. If you want to call that 1/6, go ahead. 3x minus sine 3x cosine 3x. A lot of people mess this up because they just put x's here because they memorized sine squared x. And so they negated the whole 3x thing. Okay, number 3. Secant cube, tangent cube. So u, well, we're not ready for u yet. So we got to decide what we're going to put this all in terms of. Okay. If I want to put it all in terms of secant, then I need to have a secant and a tangent left over for my du. If I want to put it all in terms of tangent, then I've got to have a secant squared left over. Right? So essentially, in order to put this in terms of tangent, the power on secant has to be what? Even. Right? The power on secant would have to be even. It's not. So I can't put this in terms of tangent. So we're going to put it in terms of secant. So I'm going to write that as secant squared times tangent squared. And then I'm going to take one of these secants and one of those tangents and stick it on the end here. And we almost there. Because now I can call that tangent squared secant squared minus 1. Whoop, forgot the x. Dang it. So now u is secant of x. Du is secant x tangent x. So this is u squared times u squared minus 1 du. And then same thing again. We got to do this part. That's u to the 4th minus u squared. So that's u to the 5 over 5 minus u to the 3rd over 3rd. So that's secant to the 5th over 5 minus secant cubed over 3 plus chips. So friends, like, I'd say overall, in general, the grades on this quiz are pretty good. The last 13s and 14s and 15s out of 15. There are some of us that are not in that. We got to fix this. Like, this is just going to keep getting harder. Like, you really need to be spending time on these problems every day. Every day. you should be spending on. And if you got the ones from the the day before, practice more. This is hard. I think I told you, like the test on this, when we go to take a test over all these techniques of integration, it could be the hardest test that you have taken to this point in your life. It could be that. It doesn't have to be if you prepare for it and but the preparing for it is happening all the time. It's not happening the day before the test. If you think you're sucking at this and you're just going to continue to wallow in the suckiness and then think, 2 days before we have a test, you're going to just flip the switch and the light bulb's going to come on. It's not going to happen. Trust me. Been watching this for 20-some years. It doesn't happen. It's really hard. I was telling those girls last period, trig substitutions, which is what we're doing right now. I remember learning that in high school and thinking, oh my God, this is the hardest thing I've ever done. I remember thinking that because there's so much involved. I mean, some of these trig sub problems, as you'll see today, some of them can take up an entire page, one side of a page. One problem can take up one full page because of all the work involved. I mean, they're tough. I mean, it pulls out all the stops, U subs, powers of trigs. You got to know the trig, to draw the triangles. It covers everything. And sadly, a lot of what we're doing right now, we're doing out of necessity because we have to, because this is what they say you do in Calc2. But it's not really involving a lot of conceptual ideas in calculus. This is more a test of your endurance, of your algebra skills, of your organization, of your trig knowledge. We're not really dealing with a lot of calculus concepts, the guts of calculus. So I mean that's frustrating. I mean, it's not, it's fun when you do these and you do them right, but it's not super useful in the big picture of things. But we have to do it. Now, if you talk to someone who uses calculus in their everyday life, they're not using this. They did this because they had to, but it's frustrating. I mean, I know, I get it. So you said the homework was rough.
Yeah, I did better than I thought I would, but it was still rough.
Yeah, I mean, some tough problems. I will confess to you, I scoured that homework. I looked through all those problems, looking for a problem that had a coefficient on x squared other than 1. I looked all over for them, and I was like, oh, we're all good. But I missed it. One of them was 1 plus 9x squared. So we'll work that one out here. In fact, you want to do that one first? And then, of course, we need to do an example that involved a secant substitution because we didn't get to one of those yesterday, right? So, Jimmy, what is it? What is that problem? The 137 you said?
Yeah, it's the integral of dx over 1 plus 9x squared.
Isn't that inside of a radical?
Yeah.
Oh, yeah.
That's embarrassing. Look, I can't. This is going on the internet. I can't. Okay. So what did you do, Jimmy?
I
all I was able to do before I got stuck was change it to be the quantity of 3x squared instead of 1x squared.
Okay, I like that. So you thought of it like this. Which I like that. Because that lends itself to making this substitution. Instead of saying x equals tangent theta, we're going to say 3x equals tangent theta. Okay? So then when I differentiate both sides with respect to x, I'm going to get 3 dx equals secant squared theta d theta, or dx is 1/3 secant squared d theta. Okay? Yeah.
Fine if I just did like a u substitution to convert it just to 1 plus u squared.
No, yeah, it's totally fine.
How many more to go?
Totally fine. Yeah, that's not the only way you could. You could have also. Someone in the last period factored out the 9. And they wrote that as the square root of 9 plus x squared times 1/3. They factored out the 9 and then square root each part. So yeah, there's lots of. I'm sorry, they wrote it as 1/9 plus x squared. So there are lots of ways of going about it. Now the answers will look slightly different, but they'll all be equivalent. Okay, so sub in. What do we got? So dx is 1/3 secant squared. I'm going to take that 1/3 and then I'm going to put secant squared theta d theta. And then the radical is going to become what? Don't give me what it simplifies to, go ahead.
1 plus tangent squared theta.
Everybody agree it ends up being 1 plus tangent squared? Whoa. So here we go. 1 plus tangent squared. So that simplifies to 1/3 integral secant squared theta d theta over 1 plus tangent squared is secant squared. Square root of that is secant. So that's 1/3 integral of secant theta d theta. Huh. Now I gotta know the antiderivative of secant of theta. What the heck? You expect me to know all this stuff? Yeah. Stinks. What's the antiderivative of secant of theta? It's the natural log of secant theta plus tangent theta. Are we done now? No. Because now we got to put it back in terms of x. Now I got to draw a triangle. Good Lord. How do I label the sides of that triangle? Well, I put theta here. Tangent is TOA. Tangent is 3x. Opposite over adjacent. What do I put there? 1. Then the hypotenuse is 1 plus 9x squared radical. Look, there's that radical again. That'd be fine. Okay, so I'm going to go up here. 1/3 natural log secant theta. What's the secant of theta? Well, that's 1 over the cosine, the reciprocal of cosine. What's the cosine of theta? So ca. So secant's hack. right? I like just think of what's the cosine and then flip it. So cosine's this over this. So secant's this over this, right? What's the tangent theta? Oh, we already know that, 3x. Woo! Hey. It turns out, in terms of number of steps, that one was a relatively easy one. Because it didn't require a ton of steps. Now that little trick with the 3x, yeah, that threw a wrench into it. But in all honesty, only one step of calculus there. You see it? Where was the step of calculus? Well, maybe two. This was a step of calculus, going from there to there, because you had to differentiate. And that was a step of calculus. The rest of that was all just algebra and trig. Yeah.
Is there other forms of integral secant theta? I mean, I have the same one, but I want to.
Are there other forms of secant? That's certainly the most common one. You might see the natural log of 1 plus sine theta minus the natural log of cosine theta. But I don't think I've seen that too often. Because I just write this as, I think of this as 1 over cosine. And this is sine over cosine. Then add those two fractions. And then use the property of logs. But I don't see it that way. Yeah. Is he sitting out there?
I don't know.
Is he banging on the door?
It's been like 22.
Does he want to come in? Do you want to come in? Oh man. Okay, what you guys want to do another one?
Yeah. We do a 142.
What? Tell me what it is.
The integral of square root of x squared minus 25 all over x.
Oh, okay. So this is a secant. Okay. So we didn't get to this yesterday, but the third type of trig sub that you're going to have involve these guys. If it's of the form x squared minus a squared. If that happens, we say x equals a secant theta. And then dx is a secant theta, tangent theta, d theta. Okay? So that's the substitution we're going to make. Now, I'm curious. Did you do that?
No.
Oh, so you just bailed on it because you didn't.
Yeah, I tried some stuff on like separate papers.
But did you try to make a secant substitution? Okay. Yeah, I mean, you had to have known like that that was the substitution. I mean, I told you that that one didn't involve sine or tangent. So, okay. So you guys ready? So sub in. What's our substitution here? X equals 5 secant theta. What's dx? 5 secant theta tangent theta? D theta? Okay, so what you guys need to do right now, plug that in and simplify the integral. See if you can do it. Charles Lindbergh style. Amelia Earhart. I'll do it up here. Don't look up here. Who got it? Yeah, that's what I mean. I just want you to simplify. It simplifies quite nicely. Nicole, you got it? Did you plug in and simplify? I'm covering up my answer because I just... You did it wrong? How do you know you did it wrong? How can you possibly see what I did? I'm standing right in front of it. Are you looking over here? Oh. Gavin, did you get it? So after you plug in here, peeps, and you simplify, you end up with this. 5 integral of tangent squared. Now here's the thing, friends. If you're having trouble going from here, like after you make this substitution, to here, it's not calculus that you are struggling with. You don't know algebra or trig. Okay? And that's, I mean, now that we've identified that, we need to work on that and fix it. Okay? But this is, just plugging in, squaring, factoring, canceling, right? This is just take some big boy algebra pants. Now we're sitting here at 5 tangent squared. Now we got to put on our calculus pants. Because we got to figure out, how do I antidifferentiate tangent squared? I don't know the antiderivative of tangent squared off the top of my head. Do you know a function whose derivative is tangent squared? I don't. But it turns out the antiderivative of tangent squared is really easy if you do one thing to it before you antidifferentiate it. It's really easy if you call tangent squared secant squared minus 1. Why is it now easy? Because you know the antiderivative of secant squared. And you know the antiderivative of 1. So I'm going to go up top. What's the antiderivative of secant squared? That's the antiderivative of secant, my friend. What function has a derivative that's secant squared? Tangent. Oh, so cute. And what's the antiderivative of 1? Theta. So 5 tangent theta minus theta. Oh shoot, we're still not done. What do we have to do now? Now we got to go back to this defining moment in our lives. So x over 5 equals secant theta. Now, I'll be honest with you. Like, it's hard for me to draw the triangle based off of giving you a secant relationship. So in my head, I just flip it up immediately. I just think cosine is 5 over x. So much easier to think that way. Cosine is 5 over x. So here's theta. Cosine is 5 over x, which makes that pesky radical. So now what's the tangent of theta? From the triangle. Square root of x squared minus 25 over 5 minus, what's theta? You have 6 options for theta. If I tell you to put theta in terms of x, you could call it 6 different things that would all be equivalent. What's one of them?
Arcsecant of x over 5.
Inverse secant of x over 5. What's another one?
Inverse cosine of 5 over x.
Inverse cosine of 5 over x. What's another one? Pick another inverse relationship from the triangle. How about inverse sine of square root of x squared minus 25 over x? Or how about inverse cosecant of x over square root of x squared minus 25? How about inverse tangent of radical x squared minus 25 over 5? Inverse cotangent. You can see what I'm getting at? Just pick your inverse trig function. It's customary, I think, to go back to the one that you started with in your little defining moment there. So inverse secant of x over 5. That's what's customary. But now, can you distribute that 5 and cancel the first 5? Yeah. Can you cancel it with the second one? If I distribute this 5 right here, can I cancel with that 5? No. Right? But it can't that. Can you just leave it like that, though? Absolutely. Plus chips. Yeah.
So for creating the triangle, couldn't you just like see that you always have like whatever like whichever one you're using, so it's you're saying the square root of x squared minus 25. Couldn't you just always know that, and since you know that the Pythagorean is like a squared minus b squared, the square root of
The leg of one of the triangle, one of the sides of the triangle is going to be that radical, but
Yeah.
you've got to know where it goes.
So like if the traction is always going to be a leg and not a hypotenuse. So
If it's what?
If it's a subtraction problem, it's always going to be a leg, not a hypotenuse. You can use that fact to determine it. And then
Yes, but you still got to know which leg it is. Is it the adjacent leg or the opposite leg?
It's always going to be opposite. If it's sine or
But
cosecant.
yeah, okay, great. Then you just did all. It's.
Like something can use.
I'm not sure you're using a shortcut there. I think you're just. The shortcut is just having all that memorized in your head versus just thinking it through. I mean, sure, yeah, you can do that. I mean, like, I don't want to memorize what every one of those triangles looks like. I would just rather just think it through. It's easier for me that way. Like, the less I have to memorize, the better. We've got too much other crap to memorize. I mean, but absolutely, Samuel, you can. You're right, 100%. If the x squared comes first, it's always a leg. Like, if it's x squared minus, I should say if it's x squared minus, not if the x squared comes first, because it could be x squared plus 9. That doesn't work. So if it's x squared minus, then it's always a leg. If it's something plus x squared, it's always a hypotenuse. That makes it easier because the hypotenuse, you only have one option, right? But with the leg, you got to make sure it's the correct leg. Is it the adjacent leg or the hypotenuse leg? But I mean, it's easier for me just to draw it. Other questions? Yeah.
We do 134.
134. Did we just lose the feed? No, we're good. 134. There's somebody else watching this other than Jack McAfee. There's 3 people watching. There are 2 people watching this. What did you say, Mia? Well, just hold on. Let me erase this, and then you can just tell me what it is. It's easier if you just tell me. Then I don't have to look. Who wants to look? Okay, what is it?
The integral of 1 over the square root of 4 minus x squared dx.
4 minus x squared?
Yeah.
So did you make a substitution?
Yeah.
What did you make?
I made x 2 sine of theta.
That's what I would have done. So dx is 2 cosine theta? Okay. So d theta? So here we go. 1 over the square root of 4 minus 4 sine squared, 2 cosine theta, d theta. Looks to me like the denominator is going to be 1 over the square root of 4 times 1 minus sine squared. Oh, forgot parentheses. So what's that denominator simplify to? What's this denominator simplify to? And when it's all said and done, 2 cosine theta. Okay? Oh, Mia, I know now why you asked about this one. Because you're like, oh, crap, what happened here? You're just left with that. Everything disappeared. Well, what's the antiderivative of d theta? Or what's the antiderivative of 1 d theta? It's just theta, right? What's theta? Oh, x over 2 is sine theta. So what's theta? The inverse sine of x over 2 plus chips. That one wasn't too bad, really. You gotta remember that inverse. I mean, there's just so much to remember here. This is killing me, Smalls. I know all this stuff. How am I supposed to know all this stuff? I don't know. Just figure it out. Just figure out how to remember all that. It's hard. It seems like black magic, doesn't it? You got more? Others? We got 5 more minutes. So apparently we're going to get some snow maybe this weekend or Monday or Tuesday. I don't know. I may not see you till like next Thursday. It's possible I might see you one day next week because I'm not going to be here on Friday next week. So how am I supposed to do all this? Craziness, right? And so if we, I'm going to look through. I think I can. There's some delta math practice too, trig subs. I'm going to maybe create an assignment for that. I got to make sure that there's trig subs in delta math. I'm like 70% sure that there are. But you guys, you got to keep working on these problems. Like, it would not be unheard of for you to knock out, like, spend a couple hours doing intervals, like, and you just have to do it, like, it sucks, yeah. It's a lot.
Kind of fun.
Well, I mean, if you're weird,
Yeah.
which, I mean, I am, I get it. I mean, I don't know, like I told you, like, I don't know that when I was learning trig subs, I thought it was fun. I really thought it was fun when I did it right. But I mean, I remember thinking, oh my God, this is really freaking hard. But so much of it is just, it's not calculus that you're struggling with.
Yeah, we have like a fun thing with like derivatives. So like when you use the derivative of rotation is velocity, then it's acceleration, then it's jerk. And the term that become less standardized. Some people say bounce, flounce, pounce, but another common one is snap, crackle, pop.
Yeah. Yeah, McManus has told me about snap, crackle, pop before.
And the even better part is on the Wikipedia page, the one that sounds more official, the bounce, flounce, pounce, does not have a citation, but the snap, crackle, pop does.
Yeah, I had never heard of jerk until I started teaching calculus. Jerk actually makes sense. Jerk is what causes motion sickness. Changes in acceleration is what causes motion sickness. Apparently, that's what they tell me. Well, have a wonderful weekend. Keep working on intervals. Like, you almost have to do this until you grow up. And then do 5 more. But check the classroom. I'm gonna look through that right now. Peace be with you. Peace be with you. Yeah. Yeah, but it's inside of a radical.